All right, so today we're going to be graphing these exponential functions with an h and k value. So we're going to have some translations left, right, up, or down. Now we're going to skip the warm-up because that's a review from yesterday. So we're going to hop right into this function here. So we have y equals 1/3 times 3 to the x minus 2 plus 1. So we're going to make a table. We have x, y, and remember it's going to be 1, 0, comma 1, 0, comma 1, and 1, comma this b value of 3. And then we make that third row and multiply all the y values by 1/3. That's going to give us 1/3 or 0.33, and then 3 times 1 is 1. Then we cross off that middle line, right there, middle row right there. And now we're going to plot 0, comma 1/3 and 1, comma 1. Now the difference between yesterday and today is this minus 2 right here. I'm going to move right 2, and this plus 1, I'm going to go up 1. So I'm going to take these points and go right 2 and up 1, right 2 and up 1. Now I'm not going to connect them until I do my asymptote. My asymptote is going to be y equals 1, the same number here. I'm going to draw that in. Now when I make my graph, I want to get close to the asymptote but never touch it. So that would be my graph. Now it's going to be exponential growth because that b value is bigger than 1. Domain is always -infinity, comma infinity. Now the range. Yesterday, the range was always 0, comma infinity or -infinity, comma 0. But now we have a k value, and this one is going to move everything up 1. So 1, comma infinity is the range. And then end behavior, look at the left side is getting closer to the asymptote. So as x approaches -infinity, y approaches the asymptote, which is 1. And as x approaches positive infinity, y approaches positive infinity because the right side is going up. And I want to point out that our k value that was plus 1 up here, our asymptote was positive 1, our range had a positive 1 in it, and one of the end behaviors had a positive 1 in it. So all of those will always align if you're doing this correctly. All right, so now the next one here, this plus 3 means it's going to go left 3. We don't have a k value, so it's going to be like the ones from the other day where the asymptote is y equals 0. But let's graph this first. So we have our x, and we have y. So 0, comma 1, and 1, comma b, which is 1/2 or 0.5. Then we make that third row and multiply everything by -8. So 1 times -8 is -8. 1/2 times -8 is -4. I'm going to cross out that middle row. So we have 0, comma -8 down here, and 1, comma -4. 1, 2, 3, 4. Now our asymptote is y equals 0 because we don't have a k value. So I'm going to draw that. Now I'm going to move each point to the left 3. So 1, 2, 3, 1, 2, 3. So my graph is going to look like this. Now, this one is not exponential decay or growth because our a value is negative. So this is neither. Domain is going to be -infinity, comma infinity. our range, the range is going to be negative infinity, comma, the asymptote, which is 0 because we're going down to negative infinity right there. So now for the end behavior, as x approaches negative infinity, the y values are going down to negative infinity, and as x approaches positive infinity, y is approaching the asymptote, which is 0. And again, you can see that our range has a 0 in it, our asymptote is 0, and one of the ends is going to 0. One of the end behaviors is y is approaching 0. And we don't have a k value that there's nothing there, so it's like plus 0. So all of those align. Right. Now, numbers 4, 5, and 6, we're going to be creating functions from the wording. So it says create an exponential function, an exponential decay that has been translated to left 9 and up 6. So y equals, now it doesn't say anything about an a value, so I'm just going to make it an invisible 1. So I'm going to do 2 to the x plus 9, because that's translated to left 9, and then up 6 means plus 6 on the outside. So you could have anything right here raised to the x plus 9 power, but it has to be x plus 9. Now, number 5, create an exponential function that its parent of y equals 2 to the x. So that means it has to be y equals 2 to the x. Now it says has a horizontal asymptote at y equals 5. So that means there must be a plus 5 out here. And then a vertical shrink means in front needs to be a number less than 1. So like 1/3. So that has a vertical shrink. Its parent function is 2 to the x, and a horizontal asymptote at y equals 5. Then the last one, create an exponential function that has a parent function of y equals 5 to the x, has a range of negative infinity, comma 3, and a vertical stretch. So the vertical stretch part, so y equals, the vertical stretch means the number in front needs to be bigger than 1. So let's go 2. Now, because the range says negative infinity, comma 3, there must be a negative in front and then a plus 3 at the end. And then the parent function is 5 to the x, so it's going to be times 5 to the x power. All right, so this function has all those characteristics. The only thing that could be different is instead of a 2, it could be like negative 4, negative 11, just a number bigger than 1. All right, so that is it for this video. Thank you for watching. Make sure to like it and subscribe.